Hi everyone, here is my first attempt at a video for you guys. I'm going to do a couple problems from the 3.1 homework, the even problems that you can use as an example or to go to whenever you get stuck. So we're on page 80 of the Core Focus on Functions and Data book, and we are going to do numbers 10, 12, and 18. And I sort of set up a little template for myself so that I'm not going to be writing the whole time during this video. Okay, so I started off with number 10. We're looking at this quadratic function and we're answering some questions about it. So our first question is going to be, and I'm going to just switch to my paper over here. So we're looking at this quadratic function. And question A is, what is going to be the vertex if you look at this quadratic function? Oh, and I kind of forgot my f of x, but this is f of x equals all that. And number 10. So it's really key that you've taken your notes for this chapter because all the answers are going to be in the notes. So this is kind of the key notes that you need to solve these three problems here. Our general vertex form, which is going to be f of x equals a times the quantity x minus h squared plus k. So this here is actually in this vertex form. And to find our vertex, we just take h comma k. So if our h over here is 4 and our k over here is 1, our vertex is just going to be 4 comma 1. Our next question that they wanted us to answer is, what is our axis of symmetry? So if you have a parabola, and I'll just tell you it looks kind of like this, our axis of symmetry is the line that goes straight down the middle. So if we folded it in half, it would fold exactly on top of each other. And our axis of symmetry also lines up exactly with the vertex here. So once we have the coordinates of our vertex, it's actually really easy to find the axis of symmetry. So this should be in your notes kind of too, that the axis of symmetry will just be the line, the straight up and down line, x equals. Remember, up and down lines is just x equals some number. And the number that it equals is going to be the h from your vertex. So if we look, our vertex here was 4 comma 1, our h is 4. So that would make our axis of symmetry just x equals 4. And I'll box that there. So at the up and down line x equals 4, that's where our vertex falls on, and everything can be folded over that line to make an exact mirror image of itself. Our next question is, does our parabola, and any quadratic function makes a parabola, something shaped kind of like this. So the question is, does our parabola point up or down? So this would be one pointing down, this would be one pointing up. And the way we figure that out is by looking here at the equation in vertex form, and our letter a here, this number that's being multiplied outside the parentheses, our -3, is what tells us if it's opening up or down. So if a is negative, our parabola opens down. If it's positive, our parabola opens up. So our a we see is -3, so it's going to be opening down. Points up. Oh, I just say open up. Whoops. Okay. Our final question is does the parabola have a minimum or a maximum? So that is, does it have a highest point or a lowest point? So always, if your parabola is pointing down, you're going to have a maximum because you're going to have a highest point. If your parabola is opening up, you're going to have a minimum, which is the lowest point. So you can pretty much find this answer from the above question or just looking at A. If A is negative, you're going to be opening down and you're going to thus have a maximum. Okay, on to question 12. So 12 will be a little shorter. That one says, determine the coordinates of the vertex for each quadratic function, so just what we've been doing, finding the vertex, and tell us whether the parabola has a max or min, which again we can find from looking at the A. So this is our function, our quadratic function for number 12. K of x is quantity x minus 4 squared plus 3. And what is our vertex? So remember, we're just going to find our h comma k. Our h is the one we're subtracting by in the parentheses, and the k is outside. So here, if we line this up here, it looks like our h is 4. Our k is 3. And that is the coordinates of our vertex, or the point that lines up exactly with the axis of symmetry. All right, and now we want to know, is this a min or a max? Is this the highest point of the parabola or the lowest point? And remember, we find that from looking at our A. This is kind of an interesting quadratic because we don't have an A here. But there is an implied number here. When we have no number, there's an implied positive 1. So therefore, our A would be positive 1, positive. And when our A is positive, the parabola opens up like this, and we have a minimum. So we know that this quadratic has a minimum. And that's all for that one. Then number 18, this is one of the graphing ones. So again, if you don't have graph paper, you can just kind of do a makeshift graph, draw the lines, whatever. It doesn't have to be exact. In this case, I already set up a graph for myself. Before you do that, I think the easiest way to start, this is already in vertex form, so we can find one of our points easily just looking for the vertex. So again, looking at our rules, the vertex is going to be at h comma k. So here, our h, now look at this, it's plus 1, but we have to put it in the form of minus 1. So our h here is actually going to be a negative 1, and our k is a positive 10. Sorry, there's a thing over my phone. So once we have our vertex, I like to put this as kind of my middle point, because then our parabola will have equal points on each side of the vertex. And the question wants us to include 5 points on our graph. So I'm going to make the vertex as my third point. My x is negative 1, and my f of x, or y, same thing, is going to be 10. My vertex, I just put that into my table. And now I'm going to find 2 points below and 2 points above, and I'm just going to graph them. So let's see, we have -2, -3, and a 0 and a 1. Really, you can choose anything for x. I just think it's easier if you keep them as small as possible so that you don't have to make a humongous graph. Okay, so remember my equation is up here. Oh, I guess, no, sorry, it's this one. So -3 x plus 1 squared plus 10. So this is, I'm going to plug my x into this to get my f of x's. So if my x is -2, I'll plug in a -2 here for x. I get -2 plus 1 is -1. -1 squared is 1. 1 times -3 is -3. Plus 10 is 7. And feel free to plug this into your calculator if you're not a crazy person that does it in your head. No big deal. Okay, if x is -3, we have -3 plus 1 is -2. -2 squared is +4. +4 times -3 is -12. -12 plus 10 is -2. Now we just have 2 more points. We'll do our x as 0. 0 plus 1 is 1. 1 squared is 1. 1 times -3 is -3. -3 plus 10 is 7. And you'll start to see, oh wow, it's symmetrical on this side. That's a cool thing about parabolas, is all the y's are going to be the same on each side of your vertex. Okay, so 1, I bet we're going to get -2 here, but let's just do that. We plug in a 1 to our x, we get 1 plus 1 is 2. 2 squared is 4. 4 times -3 is -12, and -12 plus 10 is -2. Well, look at that. Beautiful. So now we're going to set up our graph. Remember, we have to pay attention to our range here. So it looks like we have to include all the numbers from -2 to 10. To make this a little bit longer, I think. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. I'll just go to 3, whatever. And -3. Okay, so now we're just going to plot our points. We have -3, -2. Oops. -2, 7. -1, 10. 0, 7. And 1, -2. And then we kind of connect our dots as best we can, try and make it curvy. Remember, it's not a linear function, it's actually a curvy quadratic. It doesn't have to be perfect, whatever. You get the gist, and this is how you would graph this function. All right, hopefully that helps. See you later, guys.